Competing with our heavyweight robot Bolt. This year we are looking at building MacGuffin. Meet Zap, a 250-pound dual spinner melty brain. So it's kind of time to stop vaporbotting and actually build something, I think. Hello everybody, I am Ben from Team Panic. Now, before any of you get any ideas or write any comments at all, at time of recording, Zap is not confirmed for Battlebots. We don't even know if there is going to be another season of Battlebots. I don't know if the selection committee is doing their thing or not. All I know is that I have applied with Zap for whatever season of Battlebots comes next. There is nothing else going on here other than that. And my own desire to actually get the ball rolling and get some experience in the heavyweight weight class. Because of course, I've been on Team Gemini, I've seen Gemini, I've been in the pits at Battlebots, I've seen a lot of heavyweight stuff, I've seen a bunch of that type of stuff. But my own design work going into heavyweight stuff, I still don't have a lot of hands-on experience with. So that's what this is going to be. We're going to do a mini-series here on this channel, building a wooden version of Zap. And we're going to start today with the drive system. And that does mean that we're going to need to go ahead and do some laser cutting. Or a lot of laser cutting. Yeah, it's a lot of laser cutting. So like I said, a lot of laser cutting. All of this stuff that you see in front of me is just enough to do one drive setup for Zap. This is just the parts for a left side drive and a right side drive, and that is it. And this took a long time. Normally you laser cut things because laser cutting is fast and easy to get like a prototype put together really quickly. This took hours, literal hours, to get all of these parts cut on the laser and get everything working. It's massive, this project. And speaking of massive, I've also started 3D printing some parts. This here is a 3D printed pulley that goes on the output wheel. This one part took 13 hours to print, and it is printed not great in terms of actual strength. There's not a lot of infill, there's not a lot of perimeters, there's not a lot of top and bottom layers. It was printed more for speed, and it was 13 hours worth of printing. Okay, we're looking at these pieces first because these are kind of the most important ones, and I also need to get them glued, so we're going to get this done immediately. Now, these parts here are the parts for the axle mount, and these parts here are the parts for the motor mount. Now, the motor mount does mount onto the axle mount, but we'll have a look at that later on probably. So at the moment, what this is all about is we have a top and bottom plate that go in here, and you'll see that this has a little cutout here so I can put a bolt and nut in through this part. So that goes in there and there, but we also have front and back plates. Now I need to work out which way around these go. This guy goes in here, and this guy goes in here, and this one goes in there. Cool, so this here is one drive setup, or one drive mount, or one axle mount. So the axle goes through there, and actually out this side, out here, this is where the wheel is gonna sit. And you'll see that this is a massive hole. That is a 50mm hole. That is for a 50mm axle to go out of. Obviously, in the final Zap design, this will all be in steel, but at the moment, it's just in wood. So yeah, there we go. That's how that all goes down, and we've got 3 mounting holes here, which are to mount to the top and to the bottom of the chassis, and with rubber wubs and stuff in between, so there's a bit of flex and a bit of play in here. So here are our tires. These are 200mm flat free tires. Now, I bought these online, I think when I was designing Bolt, so I've had them for a little while, and something interesting happened. I obviously inspected one of these early on, and I unbolted the center hub out of it and put this whole setup aside. And when I came back to this, I realized, I don't know how easy this is going to be to see on camera, but these two wheels are now different sizes. So having sat for like 1.5 to 2 years without a hub in it means that this wheel is no longer the same size as this one. The hole through the center is smaller than this one, and it has shrunk considerably. So this is our wheel. Then we've got all of the parts that got laser cut here. These parts are for the internal section. These are to kind of hold the wheel apart, space everything out. And then these parts go around the outside and will eventually be screwed into the actual rubber or foam or whatever this is of the tire. And of course, one of these will have the pulley bolted onto the outside. Now, in the final version of this, these parts will probably be kind of two separate halves that are machined separately, aluminium or a plastic of some form. I don't really know yet. I am still trying to work out exactly what material is going to be the best to go in here, because we want something that's resilient, but we also don't want something that's going to break on the first hit, because these wheels need to be able to take a really good shot. Even though they're going to be buried inside the robot, I still want them to be able to take a hit. Okay, so we've hit our first major snag, I would say, in this potential attempt at building here, and that is that the bolt holes that line up here don't actually line up in here. So if we try and cut a bolt, or put a bolt through, at the moment, it doesn't fit. It hits the wheel. It hits the rubber of the wheel, more specifically. So I don't actually know what we can do about that, because we can't bring the bolts too far further in, because if we do that, then we can't fit the bearing in and still have the head of the bolt around the outside. This is kind of the maximum size that we can do out of that. If I try and get this set up, yeah, see, so you can see that the bolt is fairly close to the actual outer race of the bearing here. That's kind of annoying. I mean, custom wheels are always on the table. That is something that other teams have done and I could definitely do. I was just hoping to be able to bulk order my wheels and not have to custom make every single one of them. It took a ton of effort to get precisely one hole, and when I tried to do the same thing on the other side, this was already here. This bit was already here. This is me in the back. Just here, there is little nicks there, and the drill didn't go quite where it needed to, because of course I'm trying to drill through the side of something which doesn't really work ever. Yeah, it just, not having a good time on this one. I don't know what I'm gonna do with this then. These wheels are obviously not what we're gonna be using for the final thing, because of course we just physically can't. The other option, of course, is to cast our own of these, but that doesn't help with this video. In fact, none of this helps with this video. All of this video was predicated on the fact that these wheels were going to mount into these hubs and everything was going to be fine. Unfortunately, everything's not fine. So I don't know what I'm going to do yet, because these are 200mm wheels, which I could try and print prototypes of in flexible filament, but that's a lot of flexible filament, and it's about the exact size of my actual printer. So I'm not even sure if it's going to be able to do that, or if it's going to be happy to do that, which is another big problem there. So I had a good bit of a think while building this, which this has come out chunky. This is quite heavy. I kind of wish I could like give feel or give weight through the camera, but yeah, this is hefty. Even just for a 3D printed and MDF laser cut part, this is hefty. Yeah, we have a pulley and what should have been a wheel, but is definitely not a wheel. One thing I am thinking is, what if I could maybe expand these? Because this wheel and this wheel, again, are different sizes, and this one has shrunk. So maybe I can like expand these somehow. I don't really know. The other option, of course, as I said, is to custom mold wheels, and we could even custom mold them around this hub. Like we could design this hub to have pieces in it, and when it gets all bolted together, we could then cast around it, and those pieces will like hook extra material into them or something, which would be quite cool. So I think what I am going to do is I'm going to try and get my printer to actually print 200mm wheels. That's going to be a bit of an issue, I think. Oh boy. Okay, it's a few days later at this point, and this project is throwing all sorts of obstacles at me that I was not expecting. First of all, let's take a look at the parts on the table. These are the boxes that I showed you earlier, now just all wood glued together. It took a lot of clamping and getting them kind of square and flat and nice, but you can now also see how they interlock. So they kind of interlock this way so that they can sit very, very close together, and I can get the wheels close together, because the closer the wheels are together on Zap, the faster the Melty will spin. So this was about as close as they're ever going to get, I think. I think there's actually a little bit more gap in between them than that. But critically, you will see that our motor mounting points actually overlap. So rather than having to be 2 motor widths with the wheel apart, we're actually getting just a little bit shorter than that, which is really, really cool. Also, our motor mount is now mostly done, or at least one of them is. This one has a 3D printed bearing holder, which we're just gonna sock a bearing in there. That's not a problem. This one, yeah, like I said, it has the 3D printed one because the laser cut version of this, the tabs didn't quite sit nicely in the base, so it like moves around, wiggles around a little bit. So I printed one to make sure I had at least one where everything lined up straight. You can also see we've got rubber wubs in here as well, which means that when everything bolts together, there's just that little bit of extra cushion for the motor, which is going to be really, really nice. The big problem that I had, or one of the big problems, because as I said, there have been a bunch of little things that have gone wrong with this. So first of all, I went to the hardware store to get the 50mm axle that I need for this. Now, I was assuming that I wasn't going to get it in steel, and I didn't get it in steel, quite obviously. But I thought that they would at least have some like 50mm dowel or some 50mm aluminium tube or something along those lines that I could get and glue into these so that I could use them as an axle. No. None of that existed. I also looked for some wheels or some replacement wheels, but we'll get onto that in just a second because we need to talk about how I fixed this problem. So to fix this problem, I took a leaf out of James Bruton's book and have printed up some spacers, and I'm going to run some square tube. So this is 30mm square tube, which is like the largest size that would fit inside the bearing and still allow me to have some printed material around the outside edge of it. So that goes on there, and it's all just going to get glued together essentially. This one is actually the wrong one for here, but there you go. So that all gets glued together, and these spacers not only hold onto here, they hold onto the interior race of the bearing as well. In actual fact, that is what this one is designed to do. It is designed to go in the front hole, which if I can do that while not looking at it, yes. And then the bearing goes on the outside, like that, bam. This is going to be a lot weaker than I was really wanting it to be, but it's a solution that works for now. So we're going to crack on with this. So now let's talk about the wheel and what happened there, because as I mentioned, I also had a look for the wheels while I was in the local hardware store. They have these, which are a 125mm wheel with a plastic insert in them, which you can actually get out. It's fairly easy to get out. You have a look right here. This one is one that is freed. They do have a 200mm version of this, which has a similar size plastic thing in it, but they didn't have any in stock when I was there. And they said they were going to have stock today, but they didn't have stock today. So I'm really, really hoping that they have stock tomorrow, because if they don't, I can't get the 200mm wheels in this video for you. However, having said that, as mentioned, I've got one of these out already and got it into the wheel stacker. So this is actually a functional wheel now. It rolls on that rubber piece, it's probably like 2 or 3mm higher than the actual spacers that are used to kind of hold everything together and hold the bearing in place and all that kind of stuff. So we can actually run on this, and because of the way everything lines up, these guys sit high enough that we could probably almost even add a base to this and still manage to drive on these very, very small wheels. However, I am not going to dwell on that for right now. It's very, very unlikely we're going to put all of the electronics into this now, because A, this video is already probably quite long, and B, I am running out of time because so many things have taken so much more time than they should have. I guess welcome to heavyweight building, realistically. And there we have one motor module. Now, I will say these motor modules have been designed in such a way that they can be multi-purpose. So obviously we need to cut this weapon shaft down, or this motor shaft down, but that's okay for now. It won't really interfere with anything. But this whole weapon stack up this motor stack up has been designed to be used for both the drive and the weapon. So as you can see here, we have this extra pulley, but this is a two-part piece here. So there's a spacer that goes between the motor and the bearing, and then you can bolt whatever you need to on the output shaft here. So in this case, we've bolted a timing pulley onto this so that we can run the wheel off of a timing pulley, which is what all of this stuff is. But we can also throw on a different belt system, or we could throw on a sprocket so that we could run a chain drive or something. This system is very, very adaptable, and it means that we only need to buy one type of motor, because we can just buy this one type of motor, build these pods a number of times, slap on to the end whatever it is we need out of that motor, and away we go. Just quickly, I also forgot to mention there are some holes in the front which allow us to mount up some belt tensioning devices so that we can tension the belt properly. So here is basically one module completed. Now I'm kind of giving you a bit of a close-up here so you can see what I've done with belt tensioning. We have M8 bearings that kind of force the belt in against this drive pulley so that there is more tooth contact on this drive pulley. There's supposed to be two of these. However, I have messed something up and I cannot get this last one in. The belt is too tight at that point. It's probably a case of I need to run these belts and let them expand a little bit, because these type of belts do expand just a touch. So we're like, let this belt expand, and then we should be able to get the second lot of pulleys, bearings into here, which would be better because we get more tooth contact on this small gear, which would be great. We do want more tooth contact on this small gear, and it all works, which is really cool. And there is a lot of resistance on this, which is interesting, because this is a fairly big gear down and the motor is fairly powerful. So spinning it does actually take some effort, which means that, yeah, spinning the big wheel by hand actually takes a fair amount of effort, which is cool. That means everything seems to be working. The final thing to do, of course, is to clamp the wheel in place. And I do mean that literally. We have a pipe clamp here that is literally just going to go down there and clamp the wheel in place. It's not the greatest solution that I've come up with, but given that all of this has been a little bit hodgepodge, yeah, we're stuck with this solution for the moment, and we're just going to run with it. I'll also say, you might have realized we have a 200mm wheel on here, because my local hardware store got some back into stock. And by some, I mean literally this one and no others, which is a problem. I'm going to see if I can find another hardware store that has another one. If I don't, then we've got a single drivetrain, and if I do, then you will cut in half a second to see the full thing with 2 drivetrains. And through the magic of video editing, we now have 2 of them. So we have a full set, a full drive set here for Zap, which is really, really exciting. They will, of course, be something along these lines in the design. Sitting there ready to go. It's very, very hard to hold these up. These, despite being wood and aluminium and 3D prints, are actually quite heavy as they are currently, which is great. Very interesting too. I wasn't expecting them to be quite this hefty, but this is probably where we're going to end today's video, with 2 working drive pods. Well, mostly working drive pods, mechanically together drive pods. The next thing, of course, that we're going to need to do is to turn around and make the electronics work for this, and also make a base. And I probably want to bolt them to a test platform that doesn't have the wheel on the ground first, just so that I know that I can control it, because that is going to be a big thing. We want to have a way to spin the wheel up without the wheel connected. I mean, we could also probably just remove the belt out of here instead. We'll sort that out when we get there. Anyway, that is probably going to be it for this video. This has been an interesting little experiment. Lots and lots of little mishaps along the way, but we've got there. This system works really well, or looks really good so far. We'll have to see how it works in the end. I also think that these new 200mm wheels that I can get from my local hardware store are really good. I'll probably, if Zap does get in, just do a bulk order of these from my local hardware store. They're a solid rubber of some kind, which is fairly grippy and looks like it's going to take a hit quite well. So these should be the way to go. Anyway, like I said, that's going to be it for this video. I will see you in the next one.